In the second video I'm doing on factoring quadratic equation using the AC method, we're going to be dealing with two problems that require slightly different solutions to solve them. The first problem is this one here. 4x squared minus 8x plus 6 is equal to 0. A, B, and C would be that on the screen. A will be equal to 4, B will be equal to negative 11, and C is equal to positive 6. So A times C will be 4 times 6, 4 times 6, and that will be equal to 24, positive 24. We need two factors of positive 24 that will add or subtract to give us the middle coefficient of negative 11. We can play around with those factors. First of all, we have 1 and 24. 1 and 24 can multiply to 24, but it cannot add or subtract to 11, whether negative or positive. What about 2 and 10? 2 and 12. 2 times 12 will give us 24, yes. But if you subtract 2 from 12, you'll get 10 and not 11. So that can't work. What about 8 and 3? 3 and 8? Yeah, that looks like it. But we don't simply need an 11, we need a negative 11. So it will have to be a negative 8. Okay, it will have to be negative 8 and negative 3. Negative 3 plus negative 8 will give us a negative 11. So those two factors now we can use to rewrite the middle term and split that the middle term into two, thus giving us 4 terms on the left side there. So let's go ahead and rewrite that into a quadratic there. And you see we have 4x squared minus 8x minus 3x plus 6 is equal to 0. We can go ahead and group those now into two brackets, two binomials as follows. So we have our two brackets there. The first bracket we have 4x squared and negative 8x, and the second bracket we have negative 3 and plus 6. So we need to factorize those two brackets separately. Find the GCF of the first bracket. What would be the GCF of 4 and 8? That would be 4. So we can bring down 4 there. And GCF between x squared and x will be x. So using the quotient rule, we can say that 4x into 4x squared will leave us an x. So we bring down that x there. And we say 4x into negative 8x, that will leave us negative 2. Now we can go to the second bracket. We have negative 3x and positive 6. We have to be very careful with what we use to factor this bracket though, because we want the contents of the two brackets to be identical. And the only way that will be so is if we use a negative 3 as our GCF for the second bracket, okay? So negative 3 into negative 3x will give us a positive x, just like in the first bracket there. And negative 3 into a positive 6 will give us a negative 2. So the contents of the two brackets now are identical. So we have x minus 2 as the two binomials in brackets there. So we can factor that into one bracket. That can be factored out into a bracket by itself. So we can do it like this. The first bracket, we have x minus 2, and the second bracket, we have 4x minus 3. So now we can go ahead and solve for x by setting both of these brackets equal to 0. So let's go ahead and do it like this. So we would have x minus 2 is equal to 0, and 4x minus 3 is equal to 0. Let's go ahead and solve for x using the first binomial here, x minus 2. So we're going to have x minus 2. We got to get rid of this 2, so we have to add 2 on this side, and that will be equal to 2. So the 2's are going to cancel each other off, leaving us with x equals 2. In the second instance, let's rewrite this for x minus 3. But here we have to add a 3. in order to get rid of the 3. And that will be equal to 3. On the left side, the 3's are going to cancel out, leaving us with 4x equals 3. But here we haven't finished here as yet, because we still have a 4 multiplying that x as a coefficient. So we need to divide both sides by that same coefficient there. So we write it as, that would be 4x divided by 4 is equal to 3/4. The x's will cancel out each other on the left side, leaving us, sorry, what am I saying? The 4's will cancel out each other, leaving us with an x on the left side. And so we have x will be equal to 3/4. So our two solutions will be x equals -3, x equals 3/4. That's that for that one there. Now, the third equation we're going to be looking at, and when we say the third equation, remember we dealt with the first equation in a separate video. So that one that we just finished is the second one. This is the third. The third equation is this one here. The difference between this one and the previous one is that the leading coefficient on this one is 1. When the leading coefficient is 1, we can skip a few steps. It makes it easy for us. Now, we do the same second step as what we would do for the others. Okay, let's denominate the values for A, B, and C here. A, the value is 1, the coefficient is 1. B, 2, C, 10. What am I saying? B, I'm sorry, B is 7, okay? B is 7, C is 10. So let me go that over again. We have here 1, that's A, 7, that's B, 10, that is C. Good. So A times C is 1 times 10, and that will be equal to 10. Sorry for the few mistakes, all right? So 1 times 10 is equal to 10. Which two factors of 10 will add or subtract to give us 7? I think we can figure that out. 5 and 2. Now this is where solving this type of equation where the leading coefficient is 1 is different from when it is greater than 1. We can skip 2 or 3 steps here. And instead of rewriting the equation as 4 different terms and putting them into brackets and then factorizing, we just go and we set ourselves up 2 brackets with x as the leading term and one of the 2 factors as the second term in each of those brackets. It is done like this. Notice x plus 5, x plus 2. We skipped about 3 steps there. And now we can go ahead and set each one of these brackets equal to 0. So we can have x plus 5 equal 0. And we can solve for x by subtracting 5 from both sides. So it will be x plus 5. We can subtract the 5 here, and that will be equal to -5. So in the first instance, x is equal to -5. In the second instance, we have x plus 2. So we have to subtract a 2. And that will give us x is equal to -2. When we simplify, x equals -2. So our two solutions for x are x equals -5 and x equals -2.